Chapter 13, Section 7, Exercise 3. We want to determine an equation of the tangent plane and determine parametric equations for the normal line to the surface xyz equals 10 at the point 125. The first thing that I'd like to point out is even if we were given just the x and y coordinate of the point of tangency, the point in question, knowing the equation of the surface, we could calculate the missing coordinate by simple algebra. Here is how we do this. We take xyz equals 10, set it equal to 0, and call this circled entity capital F. We take the gradient of capital F, so the partial with respect to x would be yz multiplied by I. The partial with respect to y would be xz multiplied by j. The partial with respect to z would be xy multiplied by k. At the point 125, filling in 1 for x, 2 for y, 5 for z, we easily get 10i plus 5j plus 2k. Note that this vector here is normal to capital F. It is also normal to the tangent plane, the plane that is tangent to capital F at the point 125. And if we have a normal vector to a plane, we have these necessary coefficients to give us the equation of the plane. So the equation of the tangent plane is 10 times x minus the x-coordinate of tangency, which is 1, plus 5 times y minus 2 plus 2 times z minus 5 equals 0. You can easily solve this for z. I will skip right to the solution. Z equals negative 5x minus 5 halves y plus 15. That is the equation of the tangent plane to the surface xyz equals 10 at the point 125. Notice again with these coefficients, with this normal vector, here we have the vector, as I said before, that is normal to the surface and to the tangent plane. The line that passes through this vector, the normal line, has parametric equations. X equals the x-coordinate 1 plus the coefficient 10 times t, y equals 2 plus 5t, z equals 5 plus 2t.